All right, and we are going to keep on moving through. We're on question number 22. So back here, 21, I already entered. Question number 22 says, an expression is given where x does not equal 0. We've got 4x squared minus 18x plus 6 all over 2x. And again, every fraction is a what? Every fraction is a division problem. I'm going to take this division problem and I'm going to divide each piece of the top of my polynomial by that 2x. So I'm going to rewrite it. 4x squared minus 18x plus 6. And I'm going to put that divide by 2x under each piece. So I haven't done any math yet. I just broke up this into 3 separate pieces. Now, what is 4 divided by 2? That's 2. What is x squared divided by x? That's just x. If x times x equals x squared, then x squared divided by x equals x. A negative over a positive stays negative. 18 divided by 2 is 9. X divided by x is 1. 1 times 9 is 9. Plus 6 divided by 2 is 3. And our x stays at the bottom. And we can see our answer is here at answer choice A, because all of these have exponents left. And when we simplified, we didn't get that. You can practice this in IXL, multiplying and dividing polynomials, on lesson B48 in IXL. And that was answer choice A. Number 23 says an equation is given. Which type of function does the equation represent? And you can just look right at this and look at your reference sheet. And you're going to find that this looks most similar to this right here, which is our vertex form of a quadratic function. And a quadratic function always has some sort of x squared in it. A cubic function would have a power of 3. An exponential function would have a power of x. And a square root would have some sort of square root of x. So that is definitely the answer there. And to solve that, really, you just need to match up this function to your reference sheet. And it does look very similar to our vertex form of a quadratic function. Question number 24 says a function is given. How can h of 15 be evaluated? And when you're evaluating a function, we did this in IXL on lesson R96, and we practiced using your Florida Decimals calculator. And what you do is you take this 15 and you plug it in for every x. So the h of 15 would be equal to 1/5 15 squared, x squared. What is 15 squared, right? Is the square of 15. The square of 15. The square of 15. It's there for all of them. And what does this parentheses with the number outside mean? It means that you're multiplying. Multiply 1/5 by the square of 15. Not the square of 1/5, because the square is with the 15, not the 1/5. Multiply 1/5 by the square of 15. Multiply 1/5 by the square of 15. And is there anything that we're dividing by 15? No. So our correct answer here is answer choice A. Let's see here. Number 24, answer choice A. And if we continue looking to question number 25, we have a word problem, a data table, and we got some keywords in the answers: bivariate, univariate, numerical, categorical. So really this is like a vocabulary question. Which pair of terms describes the data? Maribel asked a random group of upper class students at her school which grade they're in and how they travel to school in the morning. The data are shown in the segmented bar chart. Which pair of terms describes the data? So if you look at this, we can see things are being put into categories or numbers. We can see bus, car, walk, and those are categories. So for here, we're classifying categorically, not numerically. And then bivariate, univariate, do we have bivariables or univariables? How many wheels are on a bicycle? Bivariate means two variables. Univariate, how many wheels are on a unicycle? Univariate means one variable. And what do we have? We have 11th and we have 12th graders. So we have two variables. So we are looking at bivariate categorical data. And I did not find this really in IXL. It's probably in there, but I didn't find a lesson for this. Bivariate categorical. Question number 26 says an expression is given, which expression is equivalent. And here you can look that you have something outside of parentheses and know that you are using the distributive property. R times 1 is not R cubed, so that's not it. R times R is 2 R's, that's R to the power 2, not R to the power of 3, the R's are wrong. R squared times R is R to the power of 3, our R's are good. Here, R squared times run is not R to the power of 3, so that's not right. The correct answer for number 26 is answer choice C. Again, I didn't put this one in IXL either, and I want us to just keep on moving forward to a next question. My Ray dog is going off right now, telling us that it's raining outside. So sorry if she's making a little noise. Question number 27 says the graph of a line is shown. Which equation represents the line? And if you look at these equations and compare it to your reference sheet, it's a straight line. So I'm looking over here at the linear functions, and all of them equations look like y equals mx plus b. Y equals mx plus b, which is a particular type of a linear equation, which is the slope intercept form, where it gives you your y-intercept. And slope is the letter M, and your y-intercept is letter B. So what is our y-intercept? It's a little bit over the 4, and it's positive. So that's a negative y-intercept, that's a negative y-intercept. And now, oh, they're so mean to my old eyes here. I need to see if my slope is 5 over 3 or 3 over 5. So I'm going to zoom in, and I'm looking for corners. This looks like it's on a corner. Not a corner, not a corner, not a corner. This looks like it's on a corner. And between my two dots that are in the corners, right, these are the corners, we're going up 1, 2, 3, 4, 5. We went up 5, and we went to the right 1, 2, 3 over 3. And your slope is your rise over run. Oops. So we went up 5, we went over 3, so our slope is 5 over 3 in front of the x, 5 over 3. Answer choice D is correct. And question number 27, if you want to practice this on IXL, we have lesson 9GW in IXL. And that's going to be it for this video, and that's going to be it for me for tonight, because my poor little Ray dog is really, really going off. She's about to start barking and crying, and she's shaking, so I gotta go tend to that dog. I hope you guys have a good night. I hope you're getting in some studying so that you have a really good day when you go in to take your algebra EOC and you pass that test. If you're my student, I will see you back in class. If you're not my student, then maybe I'll see you on the next video when I'm able to get that copied. I hope you have a good night or good day, whatever it is for you, and I'll catch you next time. Bye.